All right. Hi, everyone. Hello. Am I audible to all of you? Can everyone hear me? Awesome. Great. All right. Welcome to today's session where we are going to kind of have a problem solving session as well as a little bit theoretical session as well. We have to cover a bunch of small topics. Okay. Is there anyone who is also in the interview prep batch among all the students who have joined? कोई ऐसा है क्या? Okay, only Ronit. Okay. Yesterday we had a very heavy class in interview prep. We did and it happened 9 to 11 only. So 12 hours pehle hi tha. Like we did a bunch of very hard questions, I think, in the class. Okay. All right. Let's get started. First, let's start with a question. Okay. And then let's do the basic concepts that we need to do post that. Okay. I am sharing the question. Let me share my screen. Let me know when my screen is visible. Okay, just to clarify, I think the agenda for today's session is we will solve a bunch of problems, right? We had to do the break and continue keyword. Break we already did. Continue we will do today. We have to talk about ternary operators. And we have to do typecasting. Okay, all right. Let's start with the problem first. So how many of you know about Fibonacci? Okay. All right. So the question is that you will be given integer value n, and you need to find out the nth Fibonacci number. So those who don't know, the Fibonacci sequence is like this. The first two elements of the Fibonacci sequence are fixed. After that, the next element is always the summation of past two elements. So this is 0 plus 1, 1. This is 1 plus 1, 2. This is 1 plus 2, 3. This is 3 plus 2, 5. This is 3 plus 5, 8. This is known as the 0th Fibonacci number. This is the first Fibonacci number. This is the second Fibonacci number. This is the fourth Fibonacci number. So if the input is, let's say, 5, the output should be the fifth Fibonacci number, which is 5. Right? If the input is equal to 6, the output is going to be 8th. Why? Because 8th is the sixth Fibonacci number. I hope the question is clear to everyone, right? And now you can start thinking, how would you solve this? Is there anyone who has any doubt? About the question? I hope everyone is clear. Okay, start thinking, then we will discuss together. Okay, so I see a bunch of answers in the chat. Looks like most of them are correct as well. Now we will see together how to solve this. Do I have everyone's attention? Okay. Now, for solving this particular question, what will happen is, like I told you, for example, any Fibonacci number, for example, the fourth Fibonacci number is nothing but the summation of third Fibonacci number and the second Fibonacci number, right? Now, the third Fibonacci number was what? 2. The second Fibonacci number was 1. The output came out to be 3. But then, to find third Fibonacci number also, you need second Fibonacci number plus the first Fibonacci number. So, we'll follow this order only. For example, A is equal to 0. That is the first Fibonacci, 0th Fibonacci number. B is equal to 1, which is the first Fibonacci number. Okay. What I will do is, I will start a loop count, which is equal to 1, but it will run n plus 1 number of times. So see, when the count value is actually 1, right? Now, in this case, I am printing the entire sequence also. If you don't want to print the entire sequence, right, you cannot do that. I am just showing you both the questions. Sometimes the question comes in the form of printing the nth Fibonacci number, or it also comes print the first n Fibonacci number. So I'm showing you the second one so that the first one becomes implicit. So we'll start with the iteration. The first iteration is count is equal to 1. In that case, what I will print is, I will print A. Okay. So this is the output. What will be printed on the screen? 0. Second step I will do is, I will find out the sum of A plus B, right? Which is going to be 1 in this case. Okay. And then whatever was the first Fibonacci number. So this is like the two values which will form the second Fibonacci number. Once you know the second Fibonacci number, now B value goes to A and this sum value goes to B, so that I can find the fourth Fibonacci number. So it's sort of like this. B value will go to A, right? So now at this point, A is equal to 1 now, right? And B will now take the sum value, which is equal to 1, because sum mein the value was 1. Okay. Next iteration. Let's say we have to find out the fifth Fibonacci number. The value of count is equal to 2. What did I tell you? First, you do print A. So print A is 1 will be printed. Sum is what? A plus B, which is the next Fibonacci number, which is going to be 2. Then once you do that, assign the value of B to A. That means A will now become 1 and B will take up the value of sum. So this will become 2 because sum was 2. Okay? Now I do count is equal to 3. Again, first I do print of A. Print of A is what? 1. Then sum is equal to A plus B. What is A plus B? 3. Right? And then just pass on the value of B to A. A is now going to be 2 and pass on the value of sum to B. So B is now going to be 3 because the sum value was 3. Okay. Next, count is equal to 4. Right? This is for the case when input is, let's say, n is equal to 4. Okay, so you have to print the first four, I would say till the fourth Fibonacci number. So this is print of A. What is the value of A? 2. It will be printed. What is the sum? Which is A plus B. What is A plus B? 5. Then take the value of B, assign it to A. Now A will basically have 3 and B will basically have 4. Sorry, B will basically have 5. Okay? Because I will also do the value of sum will go to B. Then the last time you will do this iteration, okay? Because n is equal to 4, okay? That means you have to print till the fourth Fibonacci number. The fourth Fibonacci number is actually the fifth element. So that's why this counter is going up to n plus 1, because fourth Fibonacci number is at the fifth position. Again, you will do print of A. What is the value of A? 3. 3. Then the sum is what? A plus B. What is A plus B? 5 plus 3, 8. So the value of B will go to A. Right? So this will basically have 5 now. The value of sum will go to B. So this will be 8 now. Okay? So by the time you actually complete for the input n, you complete n plus 1 iterations. Parallelly, you can, if you want, you can print the sequence also. Otherwise, when you will complete n plus 1 iterations over here, the last value which was printed will actually be your nth Fibonacci number. Okay, so this way you can actually kind of have both the ways, or both the ways you can solve this question. Okay, so this is a simple question on how you solve Fibonacci. Clear to everyone? Anyone who isn't clear? Awesome. So let's write the code for this as well. So I've showed you actually 2 questions together. One second. Now let's see the code for this as well. So this will be for, let's say int value is equal to 5. So if A is equal to initially 0, int B is equal to 1. Okay. Now there is also int count, which is equal to 1, until the time the count is less than equal to n plus 1, right? What I will do is, first, I will print the value of A, which is the very first value. Then I will try to find out the sum. Then this B value will be assigned to A, and B will take up the value of sum, and count is equal to count plus 1. Okay, so this should be enough. Let's run this. And you will see that the entire sequence is over here. Because I had n is equal to 5, that is why till the 5th Fibonacci number, everything is printed. The same, let's say you do for 13, that means you need to print till the 13th Fibonacci number. So this is how you can do that. Okay. And this is how the Fibonacci question works. Code is clear to everyone? If anyone wants a minute, they can quickly go through it once and let me know in case they have any questions. Five means that you have to print. So if I give 5, that means print till 5th Fibonacci numbers. Okay. If you want to print the first 5 Fibonacci numbers, then just run the loop like this, right? So again, this code is very reusable in that sense. Okay. That if it says that you need to print till the 5th Fibonacci number, right? So the 5th Fibonacci number is 5. So you will print 6 values. But if you want to print first 5 Fibonacci numbers, then just make the loop run one less time. If you need just the 5th Fibonacci number, then also you can get it. Clear to everyone? So you can see this. The third Fibonacci number is 2, right? But third Fibonacci number is present at the 4th position. So that is why 4 values are printed. Clear, Rakesh? So this question can be modified to print till the n Fibonacci numbers, print first n Fibonacci numbers, and then print the nth Fibonacci number. All can be taken care of for this single code. Everyone is clear? Yes, no? Vimal, we will do this using recursion. Abhi, we have not introduced the concept of recursion. That's why we are not doing this. Okay? Rakesh, is it clear? Mukesh? Why am I seeing very less yeses in the chat? Awesome. Great. All right. So the next, we will actually now kind of keep jumbling up in between so that we don't get bored. Let's do a little bit theory now. Okay. So the next thing that we are going to now talk about is the continue keyword, right? Like I told you, Java actually has a certain set of words with a predefined meaning, which it does not allow you to create variables with, right? One of those important keywords are break and continue. Break we have already seen. So here now, we will talk about the continue keyword. So what does happen is to say in a basic idea, the continue statement basically skips the current iteration of a loop, right? For example, that loop could be for, while, do while. So what break does it? It actually breaks out of that particular loop, right? Continue actually just skips that particular iteration, right? For example, let's say I do this. Okay, so let's say I write a for loop. Like this. And then I'd say if I is greater than 4 and I is greater than less than 9. Okay. Any point of iterations in which while iterating, I becomes greater than 4 and also is less than 9. Then you do continue. Okay. Otherwise, you just print the value of I. Let's see what happens when I run this. Now, if you will see the output over here, what actually happened was the value of I is equal to 1. We checked, is I greater than 4? No, right? So in this case, we basically print I. Okay. I is equal to 2. Is I greater than 4? No. So we basically print I. I is equal to 3, right? Is I greater than 4? No. So we print 4. 3. I is equal to 4. Is I greater than 4? No. So we print I. Right? So then is I is equal to 5. Is I greater than 4? Yes. Is I less than 9? Yes. So in this case, you do continue. So if there would have been break, you would have directly come over here at line number 15. But since it is continue, what it does it actually just skips the rest of the code written after continue, right? And starts the next iteration of I is equal to 5. Okay. Then I is equal to 5. Then I is equal to 6, 7, 8, 9. All will have continue. Last is I is equal to 10. This condition is not satisfied, so you execute it. So the moment you come across continue, what it does it just skips that particular iteration and just moves to the very next iteration after that. Okay, that is what exactly continue statement is. Clear to everyone? What does continue actually does? Because I'll give an example now and you have to answer that question for me. Yes. Okay, now I'm going to go one step forward. Now I'm going to write something else and kind of expects you to see like how everyone performs on that. Int I is equal to 1 and then j is equal to 1. Okay. Then I do while I is less than equal to 3. You have, let's say, outer loop, this. Okay. While j is less than equal to 3. Okay. If j is equal to 2, I will do j plus plus. And then I will do continue on top of that. Okay. And then I will do not here, in this loop only, inner loop, this. Okay. And then let's say I do, because for j is this loop, there should be initialization, there should be update, right? And there should be a condition as well. So that is happening. Okay. And then I will do this I plus plus for the outer loop. To show you the entire code in one single screen, this is what it is from line number 17, right? And line number 30 to line number 33. Now, what I want is, I want you all to pause over here and first see what exactly the output could be for this piece of code. And then I'll help you out with the answer, final answer. And I'll explain the logic of how that works. Guys, I need the answer, like the out, what will come in the output. Okay. Ronit is correct. Aditya is correct. Dinesh, no, that would not work. I will give another minute. Arjun, what do you think? Milind, Paras, Rakesh, Rohit, Sanjeev, Sarvana, Sayantika. Nobody wants to give a try? Why do I only see always 2-3 people replying? Either others just sit and listen, they don't want to make any effort. No, Arjun, that is not the correct solution. Same, Puneet, that is not correct. Now I will start unmuting people randomly. वो better होगा क्या? ठीक है, ये कर लेते हैं. You guys don't reply in the chat. I will randomly unmute someone and ask them to tell the answers. And I will do that this later. ठीक है? We always here at AlgoCamp do old school learning. तो जैसे आप JEE mains में पढ़ते थे ना कि जाके टेस्ट देना होता था every week. You have to give test every week, right? Question class में live, someone can ask you anything while they are teaching something. That is the way of learning जहाँ पे you actually come prepared for the sessions. Otherwise, you just wake up in the morning on Saturday and sit in front of the session. So I will start doing that now. Chalo, let's see how this would actually work. Let's do one thing to parallelly show also and see the code as well. We'll do this. All right. So now I hope everyone has given a thought and we can see how this would actually work. This is a good example of nested loops as well.
So by default, initially we have I is equal to 1 and we have j is equal to 1. Okay. So we check, is I less than equal to 3? Yes. So we have I is equal, we'll do the first iteration with I is equal to 1 and j is equal to 1. Okay. What is line number 21 says? It says to print outer loop 1. So that will be get printed. Okay. We check, is j less than equal to 3? Right. So this is the point where I is equal to 1 in the outer loop. We check, is j less than equal to 3? Yes, j is actually less than equal to 3. So keeping I is equal to 1, there will be another internal loop which will start for j is equal to 1. So j is less than equal to 3. Is j is equal to 2? No. So what will I simply print over here? I will go ahead and simply print inner loop 1. Okay. All right. And then I do j plus plus, right? So that means I come over here only because this is the loop which is we are currently executing. J is equal to 1. J is not equal to 2. I print, I do j plus plus, right? And only when you complete this while loop is when you actually come to line number 32. Now I check, is j is equal to 2? Keeping I is equal to 1, now I am at j is equal to 2. Is j is equal to 2? Yes, j is indeed equal to 2. So what do you do in this? First of all, you make the value of j is equal to 3 in this particular iteration, or let's say rather show it like this, that in this iteration, you basically incremented the value of j, right? Made j is equal to 3 and then you did continue. Okay. So nothing basically gets printed. Now you come back to this statement again, because the moment you come across continue, both of these were not executed. Now you check. You run the loop third time for j is equal to 3. Is j less than equal to 3? Yes. Is j is equal to 2? No. So what do? You basically print inner loop, which is 3. Okay. And then you do j plus plus. So now we will try to run this iteration for j is equal to 4. But the condition is not satisfied because j has to be less than equal to 3. So now because I cannot do any more iterations and this while loop is completed is when you do I plus plus. And now this was the outer loop, right? And the second iteration of this outer loop will basically execute where I is equal to 2. Everyone is with me so far? Then only I will move forward. Okay. All right. Moving forward, right over here, what will happen is we have I is equal to 2 over here. Okay. Now I is equal to 2. The condition is I less than equal to 3? Yes, it is. Right. And remember, our variables are I is equal to 2 and j is equal to 4 right now. Now we basically do outer loop and then print. So this will basically have outer loop and then the value of I, which is equal to 2. Okay. We check, is j less than equal to 3? No. Why? Because we just saw that the value of j is equal to 4. So this all code, all of it will basically not be executed because the condition for j is not satisfied, right? Then I will simply come to I plus plus. Okay. So then what does that mean is I just printed something, did not do an internal loop and came out. Now the value of I is equal to 3. Okay. Now I is equal to 3. You will print outer loop, which is 3, right? You check, is the j value less than equal to 3? No. The j value is still 4. So this while loop will not be executed and you will simply do I plus plus. You will increment the value of I. So now the value of I will basically be 4, right? We check, is I less than equal to 3? No. So nothing gets printed. So what we did was overall, we did 3 iterations of I. Inside one of the iterations, we executed another while loop 3 times, right? And for the rest of the iterations, no internal while loop basically got executed. And this is your final. So this will kind of help you to understand both the concepts of nested loops, how this one loop can be nested another loop, right? And how does the concept of continue works as well. So it's not like if I do continue, it's not like if I mention, let's say, continue over here, it basically continues me out of this outer loop also. No. If the continue is present inside a while loop, then only this iteration will basically be skipped and not this entire outer loop iteration. That is what the overall idea was to introduce this over here. And I hope this is clear to everyone. Any questions, any doubt? Everyone is absolutely clear? The people who have attended all the previous classes, they will not face any issues understanding this. Awesome. Let's go back to our previous view. Over here. Okay. So this was a small topic I wanted to cover about continue keywords. Next, let's also cover very quickly ternary operators. Okay. So next we will talk about ternary operators. Okay. So know that in Java, right, a ternary operator can actually be used to replace the if-else statement in certain situations, not all situations, but it can actually replace the if-else code with a single line in certain situations. Okay, so a ternary operator, what it does, it basically evaluates the test condition and executes a block of code based on the result of the condition. My screen, okay, you cannot see, sorry. Can you now see? Okay, I will repeat once again. Right now, we are basically talking about ternary operators, right? Ternary operators are those operators which can basically be used to replace the if-else statements in certain situations. Okay, not all situations. So it will actually use a single line to replace a certain block of if-else code. Now, what it does, it basically evaluates the test condition and then executes a certain block of code based on the result of the condition. Okay, the syntax is very simple. The syntax is that you do condition question mark. If the condition is true, then expression 1 will be executed. Otherwise, expression 2 will be executed. So the ternary operator takes 3 operands: condition, expression 1, expression 2. That is why it's called ternary operator, 3 operands. Okay. Now we'll see a quick example for this to understand what's happening. Okay, so let's say int marks is equal to 75. Okay, somebody scores 75 marks. So the ternary operator will sort of check conditions like this. The condition is if the marks are greater than 70, this is the condition, right? Then the person is pass, otherwise the person is fail. So this is what you do when it is true, then this is what you do when it is false. So these are strings. So what I will do is, based on the student marks, I will store the result like this. Okay, and now it's very simple. You can just basically print the result, which will be pass. If you had to do the same thing, probably let's say in if else kind of a thing, you would have done something like this. Int result 1 is equal to empty string so far, right? Then if the marks are greater than 70, then sort of like result is equal to pass, right? Else, and so on, right? So this is how it would have sort of looked like if you would have used if else. But like I said, ternary operator kind of makes the code kind of very easy and a single line for you to write better quality written code. So there is no optimization in how the code runs over here, right? It's just that it kind of makes the code a slightly more prettier and slightly more readable for others. So the use of ternary operators actually makes our code more readable and clean. Okay, but ideally you should use ternary operators only when these result statements are small. For example, in this if condition, you have to write 20 lines of code, okay, to basically see if a particular condition is true or not. In those situations, ternary operators are not really used as such. Okay, there you should use a normal if else only. But the resultant statements, if they are short, crisp, and just test the very simple basic logic, then you should be using ternary operators. In those cases, they are very, very useful. Clear to everyone? Okay, so try to use these ternary operators also. They're actually very good to use. Okay, so next, another small topic we will cover, or do you guys need a break first? It'll take around 20 minutes to do that topic, 20-25 minutes. Do you guys want to continue, or do you guys want to take a quick 5 minutes break and come back? Only Paras and Rakesh wants to continue. Okay, everyone is okay, right? Okay, then let's not take a break. Anyway, these are not very heavy topics. Okay, if anything of sort of that type would come, I will give a break myself. Okay. All right. So the next thing that we are going to talk about is the concept of typecasting. Okay. So the next topic is typecasting, and typecasting is very, very important in Java. Okay. So what does the concept of typecasting means? That it is basically a method, right? Or a process that converts a data type, right, into another data type. Okay, in both ways. So there are two ways to do this typecasting. Either you can do it manually, or there are ways where the typecasting happens automatically as well. Okay, the automatic conversion which happens is actually done by the compiler, right? And the manual conversion is actually done by the programmer himself or herself. Okay, so now we will discuss typecasting and its basic types, and we will take proper example. Okay, so no, the ladder is sort of like this, right? The shortest data type is what? Byte, right? Then we have short, right? Then we have int, right? Then we have long, right? Then we have float, and then we have double. Okay, so the typecasting is basically of two types. Okay, the first is implicit typecasting. Okay, the other word is automatic typecasting. The other word is widening typecasting. And some people also call it as casting down. Okay. That means when you have to convert, right, a smaller data type into for example, a bigger one, right? For example, let's say, and this is the thing which kind of, I would say, happens automatically. For example, the thing is, but I think I said the opposite. It is this way. This is known as widening typecasting. This is the typecasting which happens automatically, where you can convert one, I would say, a smaller data type into the bigger one, which basically happens automatically. Okay. The other one is basically narrowing typecasting. In narrowing typecasting, what actually happens is, right, this is the second type of typecasting, where you move from a bigger data type to a smaller data type. So this is known as narrowing typecasting. This has to be done manually, right? So this is also known as explicit typecasting. Okay. Also known as casting up. Okay. So make sure you remember this order, and we'll take a quick few bunch of examples now to understand what is happening. Okay. So over here, I will divide it into cases. Right? For example, byte BHAI is equal to 10. Okay. So, and let's say short SH. Now I'm adding different variables. SH is equal to 10, and IN is equal to 10, and long LO is equal to 10. Okay. All have the same value. So if I do this, right, where the value of short, which is bigger, right, that basically gets assigned to byte. That is wrong, right? That is not a typecasting which happens automatically. When a bigger data type short has to go for smaller, this is not a automatic typecasting. Okay. Similarly, this will also not allow you to do that, right? This is also not allowing you to do any of. Okay. Because in this type of, in this case of typecasting, a higher data type or a bigger data type is going to a smaller one. So this is not valid, but this is valid. Where a byte, a smaller data type is going to a bigger one. And it happens automatically. See, I didn't even have to mention anything. And this kind of typecasting happens automatically. Okay. Similarly, but this will not work, where int is basically going into short, right? Because int is bigger. Same, this will also not work. Okay. Where long is going into short. So this is wrong. Okay. Same is the case of, let's say I do int is equal to byte. So byte can go into long, right? That is not an issue, right? Short can go into long. That is also not an issue, right? But long cannot go into short. So this will basically throw error. Okay, because long is bigger and short is smaller. Okay. Another one could be, now this will work in all cases. Byte can go into the long. Okay. Short can go into the long, right? And long can also take up the value in integer, right? So this is what basically means when we talk about implicit and explicit typecasting. Okay. How a smaller data type can go into bigger data type, right, automatically, but the bigger data type cannot automatically go into smaller one. There is a way to do that, but there is no automatic way to do that. a human intervention by the programmer is required, which we will also see. Clear to everyone so far? Awesome. Let's take more cases. Okay. So the next case is simply just taking byte and showing you an example. For example, we have case 2. Byte is equal to 100, let's say. Okay. And I do for byte b, another variable 0, b is less than equal to 128, right? And I do b plus plus. Okay. You can simply just print hello in this case, right? So you can see, first of all, the basic thing is that we can change the value over here, right? And since over here, and since byte in these does have the range of -27 to 128, right? And if I'm just taking from 0 to 128, it should not throw me any error and basically print whatever is mentioned over here. Okay, this is a simple example of how loops work. Another thing that we need to do the same is to understand the same concept for float and double. Okay, let's say float f is equal to 5.6f, right? And double d is equal to 6.7. Okay, now this is not valid. Float cannot take a double value because double in this case is actually bigger. So it will do this, but what it will actually do is, you can see it is throwing me a error, right? But this is valid. D is equal to F. A floating point value can very well go into double. Okay. So this is invalid, but the second one is valid. Okay. Let's talk about next case. So I told you, although a bigger data type cannot go into smaller data type automatically, there are manual ways to do that basically over here. Okay. So what happens is, for example, there is a value float, right? And then let's say it needs to go into int. Okay. Now I already told you in this diagram over here that float is actually bigger than int, right? One second, my laptop actually has become slow. That's why it is taking some time to reflect the error. Okay, but know that it will throw error. Okay, so now this kind of a typecasting is not valid at all, and automatically it will not take place. But I can forcefully ask, I would say, the language to actually do this typecasting by forcefully putting int over here. Okay, then what it will basically do is, even though this kind of a conversion does not exist, it will still forcefully do that for us. Okay, that is why you will see that now it has stopped throwing error to us. Okay, and it will not throw any error, and it will allow you to actually execute this code, and the value basically will get assigned. Okay, but let's take a smaller example over here and then see what exactly is the value that will get assigned. Okay, and how will that actually work? For example, let's say I do byte by or byte just b is equal to something of a value 130. Okay, but we know 130 is completely invalid. Okay, so but I did explicit typecasting over here, because of which I added byte in this case. Okay, so now this kind of a code will not give you any error. And then let's see what will be the output. 1 second. एक सेकेंड ना, मेरा लैपटॉप बहुत ज्यादा स्लो हो गया. जस्ट गिव मी अ सेकेंड. लेट मी सी इफ एनी background processes are running or not. I'm not sure how so many threads got spawned. Can you all see the screen now? Let's see. I hope थोड़ा सा फास्ट चलेगा. और तो बहुत बेटर नहीं हुआ है. ठीक है. Yeah, like I was saying, what do you think will be the output over here if I print B? क्या लगता है? What will come on the screen? नहीं दिनेश, there will be no error because मैंने explicitly बोला ना कि ये टाइप कास्टिंग नहीं हो सकती है, but still do it. So error नहीं आएगा. Definitely something will get printed. Anyone else wants to give it a try? No, Puneet, that will not work. Okay, see. So now what we did was we tried to basically have 113 byte. Now we already know that the byte runs in the range of 127 to 128, right? There is a 0 in between. There is 127 over here. There is minus 126, 125, and so on. Correct? Now, I told basically over here that byte should store 130. And the compiler is very clearly saying it is not possible to do that because byte does not store 130. But still I am forcing, right? Still I am forcing ki nahi, store 130 only. So what it will do is it will kind of follow the circular aspect over here. Okay. What does circular aspect means is that here the value is 120, right? So what it will do is it will start mapping 129, right, to basically minus 127. Okay. And 130 basically will get start mapped to minus 126. Okay. So this is basically what is happening over here, right? It basically starts to go through in a loop in this case. 1 second. Are you able to see the screen? Like what I'm writing? क्या हो रहा है? 1 second. Okay, I was writing only. Now can you see? Okay, let's go through it one more time. Okay. All right. Let's run this once first to see what the output will be. And let's kind of let go of this. Okay. Okay, so you can see the output here is minus 126, right? But let's see how that output basically comes. Okay, so we know that the range of, I would say, the range of byte is basically what? Minus 128 to 127, correct? Now, what happened was I said byte to store the value 130. Right? But the compiler is very clearly shouting on the top of its head, right? That 130 is not possible and I will throw you an error, right? But I still said no, forcefully, that please no, you still have to do this. You still have to store 130 inside it, right? So what it happens is it starts to follow a circular overflow kind of like a concept. What will happen based on that is, if you will give the value 128, it will start getting mapped to minus 128, right? If you will give the value 129, it will start getting mapped to minus 127, right? And if you give the value 130, right, it will start getting mapped to minus 126. So this is how a flow basically keeps occurring and it keeps moving in a circular cycle, right? And for example, let's say over here, I give it the value, let's say 380, then it will actually follow 2 complete circles and then come around over here at the 3rd circle. So you can see the value is 124. So it actually went through the loop, completed one entire loop, then came back again and then stopped at 124. So never byte is going to take any value above 127 and below minus 128. But if you will forcefully do this, right? If you will forcefully ask it to do that, what it will follow is it will try to run in a circular loop and try to assign the values. Does that make sense to everyone? Like why 130 basically gets mapped to minus 126? Everyone is clear? How does the concept of explicit typecasting works, right? So this is how it works, and this is how it basically kind of gets implemented over here. It's not having the use case or it's not having anything specifically, right? But you can forcefully ask it to basically take care of that. Okay, let's see some questions. What's its use in real scenario? Why we want to do this? Malab, to be honest, again, I also don't come across a lot of real scenarios where we are kind of doing this. Okay? But again, we should know that there is this capability which is present and how it is exactly used. Even I kind of sometimes the constraint is for space. Okay, I think the Rakesh, the answer comes from the very fact why we do even have these data types. Hai na? Why are you even asking this question? A better question that you could be asking is, why is there even short data type or byte data type, right? Why don't we just have directly the data type long, which could actually store everything, right? So the real idea for that is that we want to save up on the space, right? We want to make sure that everything kind of fits in the space requirements that we have, and we run the code in the least amount of space possible, right? And that is why if you will take in this loop also, which I just showed you, coming back to this example, right? The byte goes up to the range of 127, correct? So if I will run this loop now, it will actually be a infinite loop over here, correct? Because the moment you touch 128, it takes it back to 127, right? So it's like this. The moment you reached 127, right? Or 128, it basically became minus 127, right? And since minus 127 is less than 128, it again kind of moved ahead in an infinite fashion. So if you will run this loop now, it will not run for a finite number of times. It will actually run infinite number of times. Clear to everyone? So this was implicit typecasting, where everything is happening by itself, right? Then we have explicit typecasting, where we are forcefully doing it, right? Some of the areas I know where you do find real life applications of explicit typecasting, although they again seem to be really less, right? First of all is mathematical calculations, right? In mathematical calculations, you have different data types, right? Now, explicit typecasting can be used to ensure compatibility. For example, when performing division between two integers and storing the result in a float or a double variable, you can explicitly cast one of the operands to a float or a double to actually get a floating point result. Do you guys remember, like when we actually in the previous module saw that if you divide an integer with an integer, you actually get an integer only, right? But then when one of the numerators or the denominators comes out to be float, right, then you basically get another type, right? So that is why if we want basically to have compatibility, let's say the outputs, we basically use that. Another use case which I know in real life applications is about legacy codes, right? In some cases, what happens is you work with legacy code. Legacy code is those codes which were written long time back in your particular organizations. Okay, so sometimes what happens is those legacy codes are written using older data types, right? Now, explicit typecasting can actually help you convert between the older data types to the newer data types that are used in your applications, making sure that there is enough compatibility and proper integration of the application. I hope this is clear to everyone. Make sense, Rajesh? Does that answer your question? Rakesh, this was just an example that I showed you of how you can store the values, right? And how does this actually overflow occurs, right? This is not a real life use case of how I would say the use case actually occurs, okay? The use case that actually occurs in the sense and where we actually use typecasting is what I just actually mentioned, right? For example, you have a legacy code, right, which was written maybe 30, 40 years back. It uses a different data types, right? But your new application that you have written, right, or maybe the APIs are going over there, it is actually basically using a different data type. So what we do is we do typecasting of those data types to these ones so that the compatibility of the application is maintained. Everyone is clear? Yes, no, clear, not clear. ठीक है, a quick 5 minutes का break लेते हैं, ज़्यादा नहीं. I'll just quickly get some water, right? And I think with the theoretical part, we're done. We covered ternary operators, we covered continuous statement, we covered typecasting, right? There is one more thing that I will cover. Okay, let's come back from the break and I will talk about that as well. Okay, so it's 1:26. Let's meet back at 1:31 p.m. All right, everyone is back. Okay, so one more case, very nice one we can talk about over here, and then we will move forward. Okay, now we talked about float, in, double, and everything, right? What if I do this, right? And then I do this. The character value goes to integer, and then I try to do this. Okay, so what I did was I did character equal to a, right? I did try to put the value of character in integer. Then let's say I try to put this. I try to put this. And then I also did something like this. Now I want you all to predict the output for all these three lines very quickly. What will be the output in all these three cases? Okay, let's see. So what happens is that basically over here, we have ch is equal to a, which is a character. Okay. Then I tried to put the value of ch in integer, right? So there is a variable integer, right? It's the data type is integer, right? So ch is basically assigned to in. Okay. So in this case, the ch is implicitly casted to the type of in, which is a type of integer, right? And then stored in it. Okay. Now over here, let's say we already know what it is, right? Let's say I'm trying to think. Okay, yeah. Like I was saying, right? Basically, what happens is that we have in, right? That is declared over here to be of integer, right? So there will be a typecasting, implicit typecasting that can happen over here, right? Now for a as the character, its data type, its ASCII value, right? Because we are dealing with integer on the other side, right? Its type over here, since we have taken this, is going to be over here. So you have seen that implicit typecasting has basically happened. Okay. Now, in the next case, what will happen is you are simply just printing the character. So there is no and nothing that kind of needs to happen over here, right? And in the last case, what is happening is, right here, int is an explicit typecast that kind of overwrites or converts the character value ch. So either one way to do this is this, right? Either you specifically do the typecasting, and even if you will just do this much now, then also it will do the implicit typecasting for you. Clear to everyone? 65 is for capital A. Okay, 97 is for small a. Everyone is clear why this output is coming over here? Okay, let's see the next step. CH
is equal to 70. S out, CH. Then I'm just writing a bunch of things and I'm just playing around with it. Okay, so this is the next statement. Now let's see how this actually works. Now I want you all to take a quick minute and predict what would happen over here as well. Like what would be the output? Think. Okay, so over here, what is happening is we have a character which is initialized with the value 70. Okay, now in Java, like I told you, characters can be represented as integers using their corresponding Unicode values, right? Now, the Unicode value of F, right, is basically 70, right? That is why we are basically printing over here the character F. Okay, so this will, for the very first line, should give a F. For the second case, what is happening is here the value 200 is explicitly typecasted to an integer. It could have been a short also, anything like that. In this case, since 200 is already an integer, this is the case where the typecasting was not required at all because it was not causing any issues in the very first place. So in this case, although you've mentioned something, it's not going to make any difference. And this will simply print the integer value 200. Okay. In the next line, what is happening is the CH is basically incremented by 1. Okay. So when you do CH plus 1, right? But here we are doing CH plus 1, but CH is actually a character. Okay. So what will happen is in this case, the result of the addition will actually be promoted to integer. Okay, so you will take character, right? You will convert it into its Unicode value. You will do a +1 to it, and the final output, although CH was a character, will actually be a integer, right? So this output is going to be an integer. But then I said I need to typecast it specifically to character. Okay. So in this case, what will happen is if CH was 70, which was F, if I do 70 plus 1, that will obviously lead to G, right? The ASCII value of capital F is 70, right? And adding 1 to it basically gives the value 71, which kind of converts to the corresponding character G. That is why when you will print over here, right, you will see the corresponding output F20 and G. Clear to everyone? Then Dinesh, you see, right, it will be a wrong, I would say, output. This is something of a character. This is something of an integer type, and then you are trying to put it into character. This is again the typical case of the variables not being compatible to each other, right? You are trying to put something in a character container, which is of the type int.
Correct? So it will not work. So that is why you need to do the typecasting over here. Here, Dinesh, because this is of the type int, right? And this is of the type characters, right? So you will either face any error or you have to do explicit typecasting, right? And what is actually happening over here is the sense that ch is of the type character. But when you type 1 to it, how can you add something to a character, right? It doesn't make sense how you can add an integer to a character. So what actually happens in this case, implicit typecasting happens, and this ch automatically gets converted into its Unicode value, which is 70, and we do 70 plus 1, which is 71. Right? And then 71 again is an integer. And when I actually do explicit typecasting to it, 71 on explicit typecasting basically gets mapped to the character G. And then we are storing it. That's why G is coming in the output. Clear, Vimal, Dinesh? Awesome. Next part. Now, let's see what will be the output in this case. Or let's say, directly, let's do here only. And this is the case. Now tell me, what do you think will be the output over here? Think carefully, understand all those conversions, and then only answer. These are just how the different behaviors exist. Okay? So we'll have to understand these this way itself. Others, what happened? What will be the output at line number 70? Okay, so let's see what is happening. So here we have ch is equal to a character plus 1. This expression a plus 1 is evaluated. Okay, now in this case, what happens is we have the both operands. So what will happen is the operation or the addition will be performed on their Unicode values. Okay, so the Unicode value of a is 97, right? Which basically is added 1 to it, which will give us 98, which corresponds to the character B. Therefore, B is basically assigned to CH over here. Okay. After that, what we have is this line, right? Now, in this expression, we have A plus CH. Okay. CH is basically the value of B, right? B character from here. CH is basically storing B, right? Now, which has a Unicode value of 98, right? Now, A as a character has a Unicode value of 97. When you will try to add both of them, their Unicode values will basically get added and the value will be 95, which is a integer 95 from this particular piece of code, right? Since the result of the addition is an integer, what we have to do is we have to explicitly again cast it back to a character to store it in CH character, right? Therefore, now 195 Unicode value goes with A with a tilde, right? On top of it, right? And that is what basically will be printed over here. Everyone is clear? Yes, no in the chat very quickly. Then I have to show just one more example. Okay. I'll unmute someone. Chalo, okay. Dinesh, let's try to do this together. Can you unmute yourself? Okay. So let's go step by step. This is a character, correct?
Yes.
This is an integer, correct?
Yes.
What we understood was when you try to add a integer with a character, it's actually, this one actually gets converted into a integer only, correct?
Correct.
So what is the Unicode value of A?
97.
We add 1 plus it. What does it become? 97 plus 1.
98.
98. What will be the corresponding Unicode character for 98?
Small b.
Small b. Very good. So CH will have small b. Sorry. CH will have small b. This is clear?
Clear, clear.
Then we have A as a character, correct?
Right.
CH is also a character. Correct?
Yes. Right.
When we try to even add two characters, then also both of them basically gets converted first into int. What is the Unicode value of A?
97.
Okay. What is the Unicode value of this CH, which is B?
98.
90. What does it become? 195. This is the integer, correct?
Right.
And we are trying to store it into a character container. Is it possible to store something of a character, to store something of an integer into a character container? No, right? नहीं कर सकते ना. एक integer value को character के container में डाल सकते हैं? Yes or no? No, right? We cannot put that. So what we will have to do is we will have to do typecasting on top of that. So 195 basically, which was the value over here, gets typecasted into a character. अब देख लेते हैं. यहाँ पर let's see. Unicode value of 195. क्या बना? A with a tilde. So that CH now has A with a tilde. This is a different character. This is not A. And then this basically got printed. Clear hai? I'm not able to hear you, Dinesh. Is it clear?
Yes, I'm clear.
Chalo, theek hai. Perfect. Rakesh, clear? Paras, where is it printing? If this confuses you, comment this out. This is just printing this paras. Sanjeev, why do you need to typecast in line number 68? This is already a character only. Like I told you, right? If an integer, we just saw an example for that. The implicit typecasting happens automatically when there is a character to integer kind of a thing. And even a character to a character also. We don't have to explicit typecast, right? Here it is automatically happening. If it is automatically happening, why do I need to do any kind of typecasting if it is doing itself, correct? Clear to everyone? I need a all yes in the chat. Okay, let's take one more example. 10 plus 20 plus hello plus 10. 2. Quickly start telling me also what will be the output. For all the cases. Aditya, can you send in the statement that you executed? Like this code snippet? I will check. Okay, now let's see what will be the output for this particular piece of code, right? First of all, always remember that the expressions are evaluated from left to right. Okay, now start from the very left. Start from the very left. The two operands are basically, I would say, integers, and the sign between them is basically int, right? So sorry, the operation between them is basically addition, right? So this will basically do the addition of both the numbers 10 and 20 and basically give me 30 so far. Okay. Now, since the following operands after that are strings, right? The addition operation basically over here, when you do it with a string and you put a plus operator, right? Or plus operation, it basically does the concatenation, the string concatenation. That means it combines two string. So what will happen is 30 was what we had so far. Now this 30 as an integer added to a string. This will become a string concatenation and 30 hello will happen. Okay. This is the way how it works, right? And after that, what you have is, right, the subsequent integers are 10 and 20. They also get concatenated because this is the string we have so far. Then you add 10 to it. Although hello, this much is a string now, and then you add a 10 to it. So 10 will be added, right? And then you add 20. So 20 will be clear to everyone. How the expressions are evaluated from left to right and how is it working? Everyone is clear? Okay. Next one. In the next one, we have this, right? What is happening in this line? There is an addition operation between 2 and this empty character, right? Now, this character is actually a space character, which has a Unicode value of 32, right? So that is why the addition operation is performed on 2 and 32. Remember, when it is character and integer, right, the character gets upgraded to its integer, or it takes up the Unicode value and an integer addition will happen. So the Unicode value of a space is 32, right? Basically gets added to 2, which is 34, right? Now this is an integer. 34 plus 5, this is 39. Clear to everyone? Next one. We have over here, now this is not a character. Okay, this is a string. When it's string and integer, then it's string concatenation instead of addition. So therefore, 2 is basically concatenated with as a string, right? So far we have 2 and a space over here. And then 5 is also added in it. So we have 2, 5. So the result is different when it is a character and when it is a string. Okay. Next one. So now in the next one, the string concatenation operator is plus, that is used between two string, hello, and then this /t. Okay, /t is basically, I would say /t is basically representing a tab character. Okay, the result of the concatenation basically will be hello, this. Okay, and then this is basically concatenated with her world, right? So this will basically happen, right? And this is, like I just told you, is a space, so it will go away, right? Because this is just representing a empty or a tab space, right? Then what may also add over here is something like this. Let's say this is also over here. Okay, in this case also what will happen is this line is also similar to the previous one, but instead of acting a character over here, a string is basically used. Since this also represents a tab character, the output will be the same as the previous one. Okay, so in this case it won't matter, right? And the last one is the expression is 2 plus and then character tab plus 3. Now the character, this particular over here, when you try to find its Unicode value, the Unicode value is 9. Okay, so the addition operation is performed between 2 and 9 first, which will basically give us 11, right, over here, right? Then 11 is basically over here, I would say concatenated and added with 3. So that is why the output is going to be 14. Clear to everyone? You can see here as well. Everyone is absolutely clear or not? Perfect. So this is it for today's session. Okay? This is a very important concept of typecasting. I will add definitely a quiz and like an MCQ test also for this, for you to get more comfortable with this idea, right? Because in aptitude test and MCQs, this kind of comes up very frequently, right? And along with that, we will also kind of, I'll also share a bunch of homework problems on loops also, because there are still a bunch of more problems that we can do to become more comfortable with this concept. Clear to everyone? Paras, what is the schedule for next week? You can summarize that. Yes. 1 second. So, abhi tak we have completed till loops, right? And we have done this part. We have done loops in Java. We have also done problem solving in loops. Okay. The next class is how do we solve multiple patterns in Java. Okay. And how do we solve? So for that, the recorded session is available. I have already uploaded this also. So if you feel like you don't want to wait till next Tuesday and watch it a little earlier, right? You can go through it over here and understand each and every, watch all these videos and see how all the patterns are working. Okay. That is for Tuesday. For Thursday and for Saturday and for the next Monday post that also, right? That is, if I check, for example, so we have today as Saturday. Okay. Then we have today is Saturday. Okay. Today is 3rd. So 6th ko Tuesday. 6th ko this is the pattern class, right? For 7th, not 7th, 8th and 10th, and then even 12th, sorry, 13th. Okay. For all of these 3 classes, I will share content worth 3 classes for DBMS, which you can go through it and study in your own time. So 6, this is the next week. Okay. And another 1 class will go into learning DBMS concepts. Clear to everyone? Paras, make sense? If you want, I can also share in this time the computer networks content also, and you can go through that as well. And I will have most probably a test post that around 15 or something. Okay. And when can I expect lead code questions solve line? They will actually solve. So abhi yahan par Rakesh, we are doing functions. Okay. We'll do the concept of functions, and the moment we touch arrays, we'll start taking questions from lead code. Okay. So on the 10th session, we can say that lead code and all other concepts will start. Any other questions to anyone? No worries, Rakesh. We'll take care. Chalo then. All right. Let's end the session. Thank you so much, guys, for attending today's session. Please make sure you practice. Next 2 weeks are going to be completely recorded content. So make sure you learn at your own pace, but you do go through all the content. Okay. All right. Thank you. Bye-bye.